Hello students, this is Kumar Physics. Please subscribe my channel Sri Sai Physics for Mains and NEET. So today we are going to discuss about the transistor. Okay, transistor. So what is meant by a transistor? The transistor is a device. The transistor is a device which is the transfer of resistance. This is the first part which is used to transfer. This is the second part which is used to transfer the resistance. Okay. In a transistor, how many number of terminals will present? The first one is emitter, second one is base, third one is collector. Okay. In the first one, emitter, doping and size. So the emitter is heavily doped. And size is moderate. Base is lightly doped. And size is thin. Collector is moderately doped and size is high. Okay. Every transistor contains these three terminals. In the transistor, the emitter, base and collector, as you observe, then this emitter base junction should be in forward bias and collector base junction should be in reverse bias. This is in the forward bias and this is in the reverse bias. Okay. There are two types of transformers. The first one is PNP. Second one is NPN. Okay. In PNP transistor, a PN junction diode to a PN junction diode, a P-type semiconductor is added to the right side. Okay. In N-type NPN transistor, to the PN junction diode, an N-type semiconductor is used on the left side. Okay. Anyway, this PN junction, both the transistor contains two PN junction diodes. So that means it contains two PN junctions. The transistor contains two PN junctions. Next, in common. What is meant by common? Means this common terminal is connected to earth. So there are three types of terminals which are common. The first one is common emitter, second one is common base, the third one is common collector. Common emitter, common base, common collector. For common emitter, what is the input and what is the output means? For common emitter, the input is base, output is collector. For common base, input is emitter, output is collector. For common collector, input is base, output is emitter. Okay. Next. So which one is preferred? Means NPN transistor in common emitter configuration is preferred. Okay. Preferred. So this common emitter configuration, in this common emitter configuration, for any transistor there are voltage gain, current gain, and power gain will present. Voltage gain, current gain, and power gain. That voltage gain is represented by AV, current gain is represented by beta, power gain is represented by PG. So in this common emitter transistor, the voltage gain, current gain are represented as AV is equal to delta V CE by delta V BE, and beta is represented by delta IC by delta IP. Power gain is represented by product of voltage gain and current gain, nothing but beta square RL by RI. This can be written as beta RL by RI. Okay. In this current gain, common emitter is beta is current gain. In the common base, the current gain is represented by alpha equal to delta IC by delta IE. So in a transistor we know that IE equal to IB plus IC. For a small change, you can write like this. Apply delta on both sides. So the relation between beta and alpha is relation between beta and alpha. So for that you can write like this. Alpha equal to delta IC by delta IB plus delta IC. That is 1 by delta IB by delta IC plus 1. Nothing but 1 by beta plus 1 is equal to beta by 1 plus beta. Okay. Similarly, when you cross each other, you will get alpha equal to how much? Beta by 1 plus beta. So implies beta equal to how much? Alpha by 1 minus alpha. Alpha by 1 minus alpha. So this value is used in current gain in common emitter configuration if alpha is what? Current gain in common base. So this beta value lies between 1 and 100 and the alpha value lies between 0 to 1. then you should convert from beta to alpha and alpha to beta. Okay, so this transistor VI characteristics graph is represented like this. So okay, this is called what? Cutoff region. Cutoff region. And this is called what? Active region. And this is called saturation region. Saturation region. So this is a voltage gain. So this region is called cutoff region, and this is the active region, and this is the saturation region. Okay, so voltage gain. So that transistor acts as a switch in cutoff and saturation region. The transistor acts as an amplifier in active region. Active region. In the case of amplifier, between the input and output there exists a phase phi. Then it is said to be out of phase. Out of phase. For a transistor, it can be used as also oscillator, which contains a feedback circuit. Okay. This transistor is preferred mainly NPN in common emitter configuration, which contains majority as electrons for current conduction. Okay. So if any transistor circuits are given with VB, VCC, IC, IB, RL, RI, then you should apply Kirchhoff rules. Okay, this is about the transistor. Okay, thank you for watching. Please subscribe my channel Sri Sai Physics for Mains and NEET. Thank you for each and everyone. Please share to the maximum number of persons who you know. Thank you.